I want to prove that these two sets are equal. So I'm going to look at all right. Sorry, Lori. Okay. Claim. See you, Lori. A equal B. How do I do that? So yeah, so the first thing to do this, so we're going to prove that A equal B. To do so, we need to show two steps. What are the steps? Step 1, show A subset of B. Okay, how do I do that? Let X is an element of A. What does that immediately imply by the proposition that defines that set in set builder notation? Yeah, so now it shows that the derivative, so X in R and the derivative of x cubed minus 12x equals 0. Okay, well, what does that mean? 3x squared minus 12 equals 0. What does that mean? 3x squared equals 12. And what does that mean? That means that x squared equals 12 divided by 3. What day is it today? It's Wednesday, so 12 divided by 3 must be 4. Yeah, Wednesday's 12 divided by 3 is 4. That's true. Okay, now what? Thank you. Okay, now I have the square. How do I get rid of a square? Square root. What's the square root of x squared? There's a math child in my heart that just passed away. Try again. Ah, yeah, and what do you call that? Absolute vodka? Absolute value, sorry. All right. And then, how do you solve that absolute value inequality? Okay, what does that immediately mean? X is an element of B. So now I've started with an arbitrary element of A. I've concluded it must be in B. What does that mean immediately? All right, you ready for some swagger? All right, and then if it's only half the proof, yeah, we got to go back and fill it in a little bit, because otherwise they won't know it's not done. Oh, sorry, I forgot my swagger. Yeah, you got to talk like a mathematician every once in a while. And when you do it, you got to sound really, really weird. That's what mathematicians are, right? You all learn to fly your freak flags out front. You all got them, but you hide them because you think other people are judging, and they are. But not in math class. Not in my math class anyways, right? Okay, so what's the second part of this? Yeah, so we want to show that B is a subset of A. All right? So how do we do that? Suppose X is in B, which implies X equals either positive or negative 2 if we're super lazy, right? Which implies, yeah, I mean, now we got to kind of think about what that implies. Well, let's go backwards that way. We could have done an if and only if there, but I decided not to because I wanted to show the flow of this thing. So what do we need to be true in order to conclude that this thing is indeed an element of A? Yeah, so well, if we take this derivative and we evaluated this thing at x equal either positive or negative 2, this is now a check, right? Okay, so let's go ahead and check that. So what's that derivative? Minus 12, and then what we want to do is we want to evaluate that thing at positive or negative 2. Okay, any suggestions? Do not do this when you submit your test. This is really lazy mathematics. 3 times 2 squared, do what I say, not what I do. That's called hypocrisy. Should run for public office. Oh! All right, so here we go. Yeah. This is 3 times 4 minus 12, which is 12 minus 12 equals 0. All right. Negative 2 squared minus 12, which is 3 times 4 minus 12, which is 12 minus 12. It's Wednesday, so 12 minus 12 must be 0. 1. Oh, God. You're having a tough Wednesday, huh? All right, so now what do we know immediately?
B is a subset.
Yeah, that x must be an element of A, which implies, sorry, April, I'm working on it, which implies that B, we've just started with an arbitrary element of B. We've concluded that it's now an element of A. What does that mean immediately? B is a subset of A. Okay, now we got the other point in that proof. And then just to smash a fly with a sledgehammer, we say to ourselves, thus, by definition, we know what? A equals B. There's a theorem that I'm going to have you read on your own. So theorem 1, classical results in subset theory. It's good to know how to read in math. It's not easy to do. Very different than reading Harry Potter. I don't know which one's more fun, but I do know which one's funner. So please read that theorem on your own. It's kind of extra information that I'm not going to refer to at this moment. All right, guess what we just did? Finished lesson 1. That's set theory. We're going to use this. You're going to need this in lesson 22. In lesson 22, we're going to solve the least squares problem, and we're going to show that the null space of A transpose is equal to the column space of A, and that says the normal equation solves least squares problem, which allows you to avoid calculus. But the null space of A transpose is a set. The column space of A is a set, and I want you to show set equality. What must you do to show set equality? How do you prove it? One is a subset of the other. So remember this. The entire reason I went through this whole lesson 1 is so that when we get to lesson 22 and I ask you to prove that the normal equations solve least squares, that you can prove the fundamental result, which is that those two spaces are equal. And when you do that, this is the structure of that proof that you're going to need. So that's called an alley-oop, except Draymond Green threw the ball and Steph Curry shot it like 4 weeks later. Right, or 8 weeks later.